This is a video about how to solve equations using the balancing method. So in our example here, we've got a picture of a balance. On one side we've got masses of h and 7, so our h is an unknown mass, and on the right we've got, you can see there's a mass of 13. And so to solve an equation, or what we're trying to do is find out what is the unknown mass. And so this picture is represented with an equation. So it's equal because everything on one side has the same value in total as everything on the other. Just like the balance, each side must have the same mass in total. So how are we going to find the missing mass? Well, if we have a balance, then we need to take away the 7 and see what balances it on that side, see what mass is left. And so to keep it balanced, we need to do the same to both sides. So we take off the 7, and if we take off 7 here, if we can split that 13 up, we need to say, well, what's 13 subtract 7? Notice we've taken 7 away from both sides. And in our equation, we can see that 13 takes 7, we can write down the answer. If we have h add on 7 and take it off again, we're just left with h. And so our mass h equals 6. Now notice that what we've done here is we've had 7 added on, and so to cancel that out we've done the opposite operation. Same number, but opposite operation. Let's have a look at another example, which is just an equation. So here our unknown is h again. This time we've got 5 subtracted, so we've got 5 less than h. To cancel that out, so we've just got h, we do the opposite operation. Same number, opposite of subtract is add. And to keep it balanced, we need to do the same to both sides. So on our equation now, that cancels out the minus 5, so we're just left with our h. 20 plus 5. And there's our answer. Let's have a look at a slightly different equation. So let's just look at the first one. So you can see on the scales, the picture, we've got a mass of 20 on one side, and on the other side we've got 4 of our unknown weights. We could do a plus a plus a plus a, but we've written down 4 lots of a, 4 times a. Now what we want to do to find out what the mass of one of these is, we need to split this up into 4 equal parts. And we do that by dividing by 4. Notice that here we've got times by 4. What's the opposite operation of times? That's right, it's divide. So we're doing the opposite operation again, same number. So we want 20 divided by 4. And that cancels out our operation there, just leaves us with a. So our value of a is 5. Let's look at a similar equation. Here we've got our unknown value is divided by 3. Now that means it's a third of a. To get a whole lot of a, we need 3/3, don't we? So we need 3 times as much. So we're going to times by 3. I have to do the same to the other side to keep it balanced. And we can work out 5 times 3. And we know that times by 3 cancels out the divide by 3. So it just leaves us a equals 15. That's our answer. Let's have a look at a couple of 2-step equations, slightly more involved. So another diagram. So you can see 2 of our unknown weights and an extra 7 balances 35. So here we've got our equals sign, it balances, it's exactly the same, that much and that much. We want to solve it, we want to find out what the missing value is, what the unknown value is. So first thing you do here is we take off the 7. Got to do the same to both sides. So if we take off that 7, we've just got the 2 m's left. Notice again, opposite sign, opposite operation. 35 takes 7 we can do. So now we've got 2 m's is balanced by what's left is 28. So we want to know what 1m is. So we need to split this amount into 2 equal halves. Notice again, here it's times by 2, opposite operation. So if we've got 2 m's, we halve them, we just got one of them, that's what we want. Half of 28, there we have it. Last example.